This is a long bio. I think I'm just going to go ahead and cut it short and say, let's get to the presentation and she can get back to her day.
Okay, well, shall I start? Everybody ready?
Yep.
Okay, I'm going to try to share the screen here, and I've found that sharing the whole screen works better than an individual window. So we're going to do that. And then I got to pull up the slides here. And how's that working? Does everybody see it? You good? Yes, no, maybe so.
Yes, good down here. Yeah.
All right, awesome. Okay. So as you already know, the title of the talk is SWR, Who Cares? And what I hope you get by the end of this thing is whether you should care or not. And we're going to talk about some areas where you might care and others where you may not care. It kind of depends. And people always ask me about this. Of course, this is a hot topic in ham radio circles all the time. So we'll start with the easy stuff. What is SWR? Is it a breakfast cereal? Somehow I think not. Floor polish? No. A way to say slower on CW? No, I don't think that'll work. An obsessive compulsive disorder? Definitely. And also called standing wave ratio. And we're going to explore a bit more about what that means and, how you might think about it, both kind of in a mathematical sense a bit and in a more physical sense. So this talk came out of this guy, a couple of people I know who are exemplars of this kind of thing, and I had a guy tell me this once that 1.12 to 1 meant that he had to tear his whole antenna system down and retune it. And I said, what? There's also many common misconceptions like resonance is 1-to-1 SWR. I bet you many people believe that. The other thing that I see a lot is that when you have forward power and reflected power, all that reflected power is wasted. Now, some power is wasted, I'll admit that, but that reflected power is not wasted. And then there's the people who just say, I feel better when it's 1-to-1. Well, good for you. I'm glad you feel better, but it's really not that necessary to be so obsessive about the whole thing. Now, if you see my talk called Ground is a Myth, this is a little bit different because SWR is not a myth. There's just a number of misconceptions about what it means and what it implies. And there's a very clear definition of standing wave ratio, which ground does not have any clear definition at all. And it does have some value, but there's appropriate places to apply it and inappropriate places as well. And we're going to try and work through some of those. Maybe you'll, by the end of this, be feeling better about your understanding. I hope so. That's the whole idea. So we're going to dig a little deeper into this subject. And if you've seen on all my other talks, it has to get a little bit technical because I think that helps you see things. And I try to pitch it so that it's not too technical, but also can give you some insight. So we'll see what it is, how we calculate it, what exactly we're measuring with this, and exactly what we should care about when it comes to SWR. And any discussion of something like this has to start with the basics. And the thing we have to study a little bit of is wave mechanics. And so we have to start with even the basic question, what is a wave? Well, I'm sorry, is there a question or something? Good.
Why are you on your phone?
Hmm?
We need to get muted.
Why are you on your phone?
Okay. I'm not able to hear what.
Turn the microphone. You can mute it. I think he just did.
What's going, am I good to go? Hello? Am I talking to the ether? Is there anybody out there? Hello, hello.
Please continue.
Okay, Well, thank you. I just couldn't hear anything, get any feedback. Okay. So you have to start with what is a wave? And, kind of clinical definition of it is that a wave is a disturbance in a field. And what kind of field? Well, it could be anything. And so the really generic notion is that it's any kind of disturbance. The ones we talk about a lot are the kind that oscillate, and they're sinusoidal. And those kind of fields are useful for radio, but they don't have to be that way. And we're going to explore some that aren't sinusoidal as well as some that are sinusoidal. And these waves can be of different kinds. We, as hams, are concerned with the electrical ones, but it can also be mechanical. They can be quantum. Quantum field theory uses this kind of notation, gravity, or anything else. But what I want to do is, even though we're primarily interested in electrical in the end, is I want to start with some simple stuff, and then we're going to look at mechanical a little bit. So we start with simple harmonic motion. This is something that usually high school physics, they start talking about this stuff, and that's where things oscillate with a sine function. And this is actually a solution to some differential equation, but we're not going to bother with that here. But the typical form it takes is A, which is some amplitude times the sine of omega t. Omega is the radian frequency, and phi, which is the phase. And so you can define the radian frequency as 2 pi f, which is our usual notion of frequency. And then we have the wavelength, which is the speed of propagation over the frequency. And it can also use complex numbers, e to the minus j omega t. If you're an electrical engineer, you'll see that is very familiar looking. And then we add in phi, which is the phase. But this is the kind of wave motion that we talk about most often. But we're not going to talk about this exclusively. So here, we'll start looking at mechanical waves. I think they're easy to understand because you can actually make it happen at home on your workbench or even in the yard or whatever with a piece of rope, for example. And if you get the right kind of rope, usually it's sort of this soft nylon rope, and it has the right amount of inertia, you can actually kind of flick it and see waves propagate. And that helps, I think, make these things real. If you just put some RF down a piece of coax, that can be really abstract. And a way that they teach wave mechanics is with this thing in the picture here. It's called a Shive wave machine, and I love that thing. I wish I had one. They're about $350. Maybe one of these days I'll get one. There's a big one at MIT in the giant lecture hall. And I never saw them use it, but it was pretty cool looking because it was so huge. So we start with traveling waves. And this is kind of, hopefully you can see the animation here where we see the wave peaks traveling from the left to the right. And you can see a point at the middle position that's moving up and down as those waves move from the left to the right. And this is a condition you get when impedance is matched. And this can be matched impedance in a mechanical system as well as an electrical system. So mechanical systems also have a notion of matching. And all the points are always changing. That's what you get with this kind of thing. And it's traveling because it looks like it's moving, like moving down a road or something like that as it moves through the medium, whatever that might be. A property of waves that we need to understand is that they are linear in these situations. So we make this assumption, which is pretty good assumption. It's mostly true, that the systems we're going to work with are linear, and that means that the waves themselves are completely independent. And so if you have two sources of waves, they'll just kind of pass through each other. And I'll give you an illustration of that. You see these two waves coming towards each other, and they actually just pass right through each other and move off in the direction they were moving when they first encountered one another. And that's because this is a linear system. You can observe this even in waves in a piece of wire, but I mean mechanical waves or a piece of rope. You can also, of course, see it in electrical systems, but they will it seems like it shouldn't work, right? They'll just move right through each other and overlay. And this is, of course, also true for sinusoids. So if we have two sine waves, and on the bottom, you'll see a sine wave moving one direction, and the other one kind of there, not moving, relative. This is relative motion. And you can see if you add them, you get sort of this adding and subtracting pattern that looks like there's a stationary wave beneath it. And that's the addition of those two. So you can kind of see where we get these standing waves because they don't seem to be moving, even though they are the product of things that are moving. In considering this, there's also something that's really important to look at, and that's called boundary conditions. And the boundary conditions define what happens when something hits something else. And so we have this rope, and let's say we flick the rope. And what happens if the end of the rope, where it comes, say, in contact with a wall, is free to move, or if it's not free to move? We get different results in those cases. So if it's, let's say the end is free, and we'll start there, and that'll be the bottom right here. You get motion, but no tension. So if we propagate a wave down, watch this, it will go down there and it'll move at the end. And you can see it kind of matching the height at the wall there. And that's what causes it to kind of bounce back because it's the only way that all the boundary conditions will be met. Now, if we hold it steady on the wall, you get a different condition that's a little less intuitive, but it comes over and matches the momentum and forces, and that causes it to flip upside down. And that's purely because it's encountering that boundary condition. Now, if you're thinking ahead, you might say, this sort of looks like shorted and open, and you would be right. So you're kind of looking at an open coax and a shorted piece of coax or something equivalent to that. But there's a lot of points in between these two. And here's an example. So here's a different set of boundary conditions where we have like a lightweight piece of rope that encounters a heavier piece of rope, and then a heavy piece of rope that encounters a light piece of rope. And in these conditions, the energy and the momentum, all of that has to match. And so when we do those calculations, what we find is that we get something in between the two that I showed you earlier, where the wall was reflecting right side up and upside down. So if you propagate the lightweight rope towards a thicker piece of rope, then what you get is it's sort of like partially held to the wall. So it goes like that. So it sends a bit of the energy back and some of it moves forward. And if you start with a thick one and go to a lightweight one, that's kind of like the one that was free to move against the wall. So you get something that comes back in the same amplitudinal direction. So you can see that you get different effects depending upon how you kind of match these pieces of rope. And the matching is the same thickness and inertia of the rope in the mechanical system. Now, how do we get those standing waves we keep talking about? Well, whenever we have what's called a mismatch, which means, I'll explain that in a little more detail, but it just means we can't transfer energy and momentum out of the system. Some of it just remains in the system. We get these standing waves, and they are not really standing still. They're just the envelope of the peaks and the troughs. And this is the thing you saw earlier with the superposition of the incident and reflected waves. It's just that now we show them moving relative to a stationary point. And so if some energy is going down from left to right, and for whatever reason, some of it's coming back from right to left, then we get this superposition that creates a stationary pattern. And when we look at, like what is the standing wave, we often look at the envelope of these resultant peaks and troughs, not at the actual, instantaneous peaks and troughs. And the standing wave ratio kind of falls out of that. It's the peak to trough of the envelope. It's that ratio. And this applies to mechanical waves as well as electrical waves. It's the same deal. And it has this rigorous definition, which is listed below the SWR meter here. So we have this thing called the reflection coefficient, and we typically call that gamma. And then that's basically the difference over the sum of the impedance of whatever and the kind of system impedance. And SWR is derived from that as some kind of vector sum, but don't worry about that too much. This is just, how the mathematicians deal with it. But the point is to show you that there is a real definition of standing wave ratio. Now, here's a really important thing to understand, I think. So we have this notion called characteristic impedance. Now, if you've ever taken a piece of coax, which has a characteristic impedance of, say, 50 ohms, and you put it on your ohm meter, well, what do you get? That seems infinite or close to infinite. So it's a different kind of notion than, say, DC resistance. But what it is the ratio of two parameters that allow for energy transport through that piece of coax or a mechanical system or whatever. So if we take whatever we're looking at, we slice it up into little pieces, we can see how the energy moves from place to place to place. So from each little slice, we'll see some energy that gets moved from one slice to the next slice to the next slice. And that ends up looking like an impedance. So if we, drive that in there and we drive some energy into that system and it goes propagate, 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 and gets to the end and gets to propagate out, and there's an impedance at the end, it will propagate off the end and then disappear into some other place. However, if there's not something on the end to take up that energy, then some of that energy is going to come right back into the system. So I'm going to run this animation at the top. Don't pay attention to the words down there, but just look at what happens as we apply a voltage. And here's like an inductor and capacitor system. And you can see the voltage is kind of lifting things up there, but you can kind of see energy propagating down this thing, coupled from each segment to the next segment as it goes down. And it's all fine as long as it's coupled from segment to segment to segment. But it gets to the end here. And I want you to observe what happens here at the end. All of a sudden, it's going way up there. And then it's making like it's going to start going backwards and the animation ends there. So it couldn't move the energy off the end there because there was nothing to take that energy up. And so it had no choice but to kind of go back because the energy has to go somewhere. And so when, whatever impedance should go there to transfer to the next element is the characteristic impedance. So what's a match? I've been kind of talking about it a little bit, but let's be more explicit. It's where that work that's done or energy, the work energy theorem says that they're both the same, gets to be transferred along rope, coax, whatever, by whatever parameters there are. But if you look at the mechanical one, force times distance, and we have that deflection and tension, and the energy goes bloop, 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 bloop down all the little pieces. And then at the very end, it gets moved to something else and does some work, or it gets stored in something else, but it has to be stored in the right ratio so that it matches the system. And here's one of those Shive wave machines. I'm going to animate this, and you'll see a couple of waves being pumped into the system by that guy standing there. And then there's a dash pot at the end that absorbs that energy perfectly, and that will cause it not to come back because that energy that's going along the wave machine is going to be turned into heat at the very end. So if we watch this, here's a couple of waves, and they're traveling down, and then it gets to the last bits of this thing, and you'll see it kind of do its little flip and take the wave, but then just damp it out perfectly like that. So it has absorbed that energy and turned it, in this case, into heat, because that's what we do with mechanical energy when we just want to throw it away. So a little bit of increase in the entropy of the universe. But the key thing here is that a match means we can propagate that energy from the transport mechanism, whatever it might be, off to the next thing, whatever that might be. So you're probably thinking about now, this is not ham radio. What are we talking about? But it is. And, we've been talking about deflection and tension of ropes and springs and things like that. But there's a direct correlation. I kind of think of the deflection like voltage, which is equivalent to electric fields. And that the tension is kind of like current, which is more like magnetic fields. And they have similar kinds of constraints, as I alluded to earlier. You know, you've got this shorted thing and the open thing mechanically as well as electrically. And it's even more than an analogy. Uh, it's actually equivalent. You know, when you do the calculations, it's the same kind of calculations, whether it's mechanical or electrical. So this is ham radio. In coax, we get the same sort of thing. It's similar to a piece of rope, but there's just a lot more dimensions to deal with. But the principles are really the same between the two. We have magnetic fields and electric fields that are propagating through the space, for example, in between the shield and the center conductor of a piece of coax. And it's the same mechanics, even though it's a lot more complicated when we have two fields to deal with instead of one thing. And, you know, those waves, they propagate actually not through the conductor, but in the space between the conductors. But the same characteristic impedance notion is in there. So each little segment of coax has to transfer energy to the next little segment of coax. And you can, you know, slice those segments as thin as you want to and observe the energy transfer from one to the next. And that's how we do it with calculus. We slice that infinitely thin. But the idea is that energy moves along the coax and we can kind of analyze it in segments. Open feedback lines is a little more obvious to think about. So, you know, because, you know, there's not this mysterious inside, there's an outside that you can look at, and you can actually put a loop of wire and a light bulb on there and actually see the peaks and the valleys of things. It just has a characteristic impedance that's different than we're used to. We just happen to love 50 ohms, but it's not 50 ohms. In most cases, it'd be very hard to make 50 ohm open feed lines doable, but harder. But it's kind of cool. It's a way of like observing it directly if you want to. Now, the Smith chart is a way that we calculate all of this stuff. We can estimate these impedances, and I know this thing looks really scary, but there's a point I'm trying to get to with this that I want you to observe. And so even if you don't get all the machinations with the Smith chart, there's one thing I really want you to get out of this. But the first thing we want to start with is that this is independent of the system impedance, and that's because it's linear. The whole thing is linear. And so we can just, right in the center, you'll notice a point 1.0, and that is the system impedance. So we can just use that directly, multiply that by, say, 50, and get all the things we need. It's not all that hard to understand, believe it or not, even though it looks really scary. And for any mathematicians in the audience here, this is a conformal map, meaning angles are preserved of that reflection coefficient gamma. So let's explore a couple of the elements to the Smith chart so you can understand a little bit about what's going on. So that 1.0 point, that thing in the middle, we call that prime center. And the prime center is kind of where we start with all of our calculations. And that 1.0 represents, you know, kind of the characteristic impedance of the system. So if it's a 300 ohm system, we multiply everything by 300. If it's a 50 ohm system, we multiply everything by 50. And then we have these circles. This is one type of circle we have on there. Those are the so-called resistance circles. And that's part of plotting out the impedance that we're going to see. And bear with me, it's going to be okay. So each one of these represents a constant resistance on that thing. And then at the bottom, we have constant reactance, and we have positive and negative. And this would be the imaginary portion of the impedance. So, you know, we have the positive and the negative reactance, which is associated with inductance and capacitance. And those are the curves that map to a constant. And they're marked there as to what they mean. And then rotation around the blue circle, that's distance from one thing to another, load or from the source. And we rotate, and that's, you know, half a wavelength. I think it's one trip around that. So all of that is normalized, though. And if we overlay the resistance and impedance constant lines and circles on one another, we get something that looks like this bottom right-hand thing. And there's, a short circuit and an open circuit that are represented on the chart. And it has this infinite point there. It's because it's kind of a hyperbolic geometry. But you can see that, like, if you pick a point on there, you can see a couple of points that are on there. 1 plus J2 is 1, and 0.5 plus J1. Those are complex impedances that you've learned about, hopefully on your extra test. And if you multiply that by 50, then you get like 25 plus J50 and 50 plus J100. J is the square root of minus 1 there. That's the imaginary component. And so there's one other circle you have to overlay on this, and it gets really busy, and that's the SWR circles, SWR circles. And so they center on prime center, and each circle represents constant SWR. And we'll look at that in a little bit more detail next. So if you want to find the SWR of some circuit you're working on, the first thing you do is you scale it to that prime center, Z0. That's the impedance of your system, 50 ohms, for example. And then you plot the endpoint on the impedance on the chart. So you have those constant reactance and resistance. You plot a point there. You make a circle centered at that prime center. And then you get a SWR circle, which is the radius to that prime center from the impedance you're interested in to the prime center. And then you get all the equivalence impedances. The radius is that reflection coefficient. So you can see the whole thing maps in here. And the SWR intersects the right-hand side of prime center, and that gives you the SWR reading. So even if you didn't understand that, I'm going to tie it all together next. So we can do the other thing where we start with an SWR that's on the right-hand side from the prime center, and then we make a circle like that centered around that prime center, and that SWR circle is constant, for example. And again, same thing as before. But the thing I want you to observe now is that SWR circle is constant SWR, right? But the thing that's really interesting is that there are an infinite number of different impedances along that circle that represent the same SWR. So if you have, say, a 3-to-1 SWR, there are an infinity of different impedance that will give you a 3-to-1 SWR. So what's that mean? This is like showing us something, but it has to have something that's interesting about it. Well, the interesting thing for me is that SWR is what I call a degenerate metric. It tells us something, but it doesn't tell us everything, because there's an infinite number of impedances that give us the same SWR. That's not really specifying something really important. And this is independent of the impedances that you're at of your system or whatever. It's still an infinite set of impedances that are all give you the same answer when you crank it through the SWR calculation. So the things we get from this is that the absolute load doesn't matter. Resistance is resistance. You just scale things appropriately. It's all linear for the most part. The wave mechanics are all the same, no matter what you do. And energy propagates. And it propagates in various media. It propagates into the fields. It propagates mechanically, perhaps. And it can turn into heat. The energy has to go somewhere. And the heat itself actually propagates in the form of infrared. So everything wants to propagate. And the question is, where does it go and what does it get converted into or not? So with all this, we've been very abstract. Let's get a little more concrete. So we have to have something that puts energy into the system. And that thing that puts energy into the system, we'll call it a generator. At least that's what they call it on the Smith chart. We, and as hams, call it a transmitter. And this is an FT100 that I rescued from death. But the transmitter is kind of this device that has a lot of confusion associated with it. what's the equivalent circuit of the generator, of the transmitter? I think there's a lot of confusion. And these things are designed for a particular system impedance. As in most modern ham radios, it's designed for a 50 ohm system impedance, but it sure doesn't have to be. A lot of systems are designed for 75 ohms, 300 ohms, 600 ohms. It doesn't really matter. It's just that there's a design constraint there that you decided to make the thing most efficient at. And tube or transistors, it's the same deal. The basic question you have to ask is, can it deliver power? Can it take that energy and push it down the coax or whatever, the transmission line that connects it from here to there? Now, I want to take a brief detour to talk about something that always comes up in this context. And I've even seen, electrical engineers with a lot of training get this wrong. And that's the maximum power transfer theorem. Maximum power transfer theorem is misinterpreted most often around the idea that the source impedance and the load impedance have to be the same for maximum power to be transferred. And that's it. That's all they say. And that leaves out a very important constraint to make that statement true. And that is that that's only true when the source impedance, RS in our little diagram here, is fixed and you can't do anything about it. So if you can't change RS, then it's true that RL will get the most power when it's the same impedance as R sub S. But it doesn't work the other way around. And so if I can change RS, things are not the same. And I'm going to show you an example of that. So it's really usually effective to try a degenerate case, and let's do that. So I want to get maximum power to a fixed 50 ohm load. Call that R sub L here. And I'm going to allow myself to change R sub S in this case. So if I change, let's assume we have a 50 volt source and R sub S is 50 ohms. Okay, so 50 ohms, that should be maximum power transfer, no? So if we calculate the power, that's B squared over R. You can see that I did the math there for you, and it gets you 12.5 watts dissipated in R sub L. Okay, well, now I'm going to choose a different source resistance. I'm going to choose 0 ohms. Now what happens? So it's 0 ohms, then the B squared over R calculation is 50 squared over 50, which is 50 watts. So if I choose R sub S to be 0 ohms, I can get a lot more power, almost 4 times power to the load. So that means that I can break the maximum power transfer theorem if I can choose the source resistance. Anyway, getting back to transmitters and transmission lines and stuff. So in our transmitter, and this is where things kind of fall apart about the maximum power transfer theorem, people assume that there's somewhere a 50 ohm resistor in here, or that the impedance of the transmitter is itself 50 ohms. But there's no 50 ohm resistor. If anything, the finals of a transmitter look more like a voltage source than anything else. And what we try to do is get that conjugate matched into 50 ohms somehow so that the power can be transferred out of that thing. The actual, this is a little push-pull circuit here with a transformer and stuff. The actual impedance of this thing is really complicated. It changes throughout the cycle, but transistors are not linear. Even the FETs are not linear. And so the impedance throughout any given cycle is a complicated matter. And that's what leads to all kinds of harmonic distortion and such that we end up filtering out. But there's no 50 ohm resistor here. It looks more like a voltage source than anything else. And even for tubes, this is also the case. It doesn't really change. But what do we really want to do with this thing? We have this circuit and it's kind of weird and it's kind of nonlinear. What do we want to do with this? Well, again, we want to get the power out. We also want to make the driving elements happy. And by happy, I mean that they are delivering power without themselves getting hot. They are within their design limits, not too much voltage, not too much current, and not getting overly hot and also staying linear. That's really important. And so we designed the circuit so that at some system impedance, often 50 ohms, that's all those things are met. Everything is linear. The tubes or transistors are happy and everything is reasonably efficient. But that's what the transmitter really wants to see. It doesn't, want to do maximum power transfer theorem stuff. Now, once we've got this generator going, this transmitter, we got to get the energy out of there. We need to move it, usually physically, somewhere else. And to do that, we use real transmission lines. Our transmission lines are obviously not ideal. They have losses, and they usually come in three flavors. There's resistive or ohmic losses, there's dielectric losses, and then there's leakage losses. And, again, the energy has to go somewhere. And usually on the Smith chart, that means you're kind of spiraling in towards the center. But the energy transmits from each little segment of coax, imaginary segments from one end to the other, and hopefully gets out the other end without losing too much. But what does high SWR in these transmission lines mean? Well, it kind of means we have higher voltage and higher current than we would have otherwise at certain points. And this may result in higher loss, usually loss to heat more than anything else, but it can also result in higher dielectric losses. So in an ideal transmission line, there would be no loss. It's just we don't live in that world. Now, loss in coax, you can actually kind of calculate it. It tends to be higher than open wire feed line, mostly because of dielectric losses and sometimes because of shielding losses. But it really depends on the kind of coax that you have, the kind of dielectric that's in the middle, how good the shield is, and things like that. And you have to kind of look it up for each type of coax because the calculations are complicated. If you have an air dielectric in there, it's generally better, but that's only a heliax. You can use the ARL match loss calculation, which is pretty handy to do online. And this is the equations, but don't worry about that. I'm going to do a little bit of this for you. So if we have a loss example, this will kind of calibrate you on how much you should care about this. So if I have some generic coax, and let's say I match it perfectly, and let's say a segment I'm interested in loses 1 decibel across that length, whatever it is, doesn't matter. And then instead of being perfectly matched, I up the SWR to 2 to 1. You can see that the loss increases by 0.2 decibels. If I make it 5 to 1, we're up to 1 decibel. 10 to 1, and it's only about 2.2 decibels in addition to the 1 decibel you'd had before. So it's not that huge when you come to think of it. Coax will give you more loss with higher SWR, but it's not dramatically higher. So this is something that you can either look, this particular graph you see here was in an article from QST, and if you're an ALR member, you can look it up. But you can see that it's not enormous. It's significant. Depends on what you're doing as to how much you care. If you're doing moon bounce, you may care about this an awful lot. If you're doing HF, it may not matter as much. It depends. Certainly VHF, it doesn't matter as much. And then, so we got this transmitter. We got a piece of, say, coax, for example, or something to move that energy. And then ultimately, we have to dump it into some kind of load. And that load is the thing that's going to take the power and do something else with it. So we try to match one thing to the other to make the transmitter happy because the transmitter wants to see a particular impedance like 50 ohms. And then we put it into something at the other end, which might be an antenna, for example. And in a typical setup, we have a choice. Do we match the transmitter to some piece of coax that came in the window from, say, an antenna? Or do we do it at the antenna? And I'm sure you've heard this before, but it's convenient to stick your antenna matching system right near your transmitter inside the nice cozy home, and then send that mismatch thing down the coax, and then you have to deal with the coax losses. That's just the way it is. But you can also match it at the antenna, and then you have a nice matched load, and a matched condition in the coax going all the way down to the antenna. And that's great if you can do it, but it's can be a real pain because that thing has to be weatherized and you have to control it remotely. So it's kind of a choice and a trade-off. If you match it out there, you got to deal with all that stuff. but it will be a more efficient system. The question is, how much inefficiency can you tolerate, or will you be worried about? And of course, then there's the matching network itself. We use inductors and capacitors to kind of null out the reactance and change the resistance using complex conjugate techniques. And we want to transform it to kind of near the system impedance so that maybe we minimize losses and we make the transmitter happy again. That's all it's about here. And then at the other end, we probably have an antenna. And most antennas are not 50 ohms. They are purportedly 50 ohms, or they may have done something to look like 50 ohms, but they generally are not. A free space dipole is 72 ohms, a free space monopole is 36 ohms. Yagis are really low impedance, under 10 ohms or around 10 ohms often. And we have to do something to fix that up. And, as we change that impedance by various methods, it may change the pattern too. And you have to be aware of that. Pattern matters as well as the amount of power you can couple into free space. But in a large sense, when you're looking at an antenna that doesn't have some kind of transformation, and that can include like gamma matches and delta matches and things like that. But if you have, and this happens with monopoles all the time, like a center-loaded, monopole antenna over a bunch of ground radials. If that matches at 50 ohms, then something is lossy. And what you'll see with these antennas is that the better you make the ground plane underneath them, and the better you handle tuning that coil and stuff, the worse the SWR gets. And that's because it's getting closer to that 36 ohms. And so if you're getting 50 ohms in that situation, probably you're heating the dirt a bit. So in the end, what do we care about? We really care about, making that transmitter happy, keeping those devices nice and cool and linear, getting that power transferred in a really good way. We want to account for the loss in the feed line and decide whether we care about it. If it's a short run, maybe we don't care at all. The long run, we might care about it. It depends on what we're after. If it's an FM transceiver to your repeater, do you really care that much? Maybe not. But maybe so. I mean, you can upgrade your coax or whatever. If it's HF, it depends on, how serious you are about DXing and really weak signals. If it's microwaves, you're going to start caring a bit more because the losses really add up. But in the end, it's about having fun and not perfection. Just try to get a situation that's good enough for you. So if you want to learn more about all this stuff, you can look in the ARL handbook. That's always a handy reference for this kind of stuff. The antenna book takes it into more detail about transmission lines and about coupling and all that stuff. There are deeper dives available on Wikipedia, but it tends to be really obtuse and missing any form of detail or prior explanation or any kind of foundation. And physics texts will always give you the more foundational knowledge that you need to deal with something like this. So with that, I will take any questions.
I have a comment, if I may.
Go for it.
This is Bob, K9RHY. And I've been screwing around with SWR for 65 years worth of hamming. And that was the best SWR presentation I've ever seen. So thank you.
Oh, thank you. I'm honored. Other questions?
Yeah, I have a question, Kristen.
Yeah.
So we have a bunch of antennas. One of them is an R7 vertical. And, when you tune an antenna with an antenna tuner on the end of the coax, you're just making the transmitter happy. You're not doing anything. You may have higher SWR on the line than you will. It's higher SWR on the line. Does that affect the voltage? Because I was tuning the R7 with an antenna tuner, and I was only running probably less than half the wattage that it's rated for, but something arced over in the match box at the bottom of it, and I'm kind of always thought that was having to do with the SWR and tuning it. Is that way off?
Yeah, that makes sense. And what you get with these standing wave ratios are peaks of current and peaks of voltage, and they're in kind of opposite phases to one another. So if you have a piece of coax that has some high SWR on it, as you move down the coax, you'll find these constants of high current and high voltage, and you might be able to measure them from the leakage fields. But yeah, it's easy to get arcing or burning along the coax if you have a high SWR, if the coax is not up to the job, or in the matching network. Because if there's a real mismatch, the matching network has to put up with some of that. And I've arced tuners over before. It's not that hard to do.
Kristen, can you hear me?
Mhm. Yeah.
Yeah, wouldn't it be better at the base of the tower to have a remote tuner, a kilowatt remote tuner?
Yes, and that's if you care about the loss, if you really want to minimize the loss in the system, that's the best situation. You just have to weatherize it and control it remotely. But not everybody, that's not practical for everybody. So it's not an egregious sin to put the tuner or matching network close to the transmitter if you just can't swing it.
Right, thank you.
Other questions?
So amplifiers and radios shut down on higher SWR because you're building up more heat in them because of the bad SWR. Is that correct?
It's not just heat. There's over voltage or over current of the semiconductors usually. And the tube ones don't care as much because tubes are kind of indestructible, not completely, but less destructible. But the transistors are really sensitive to, like too much power being dissipated or higher voltages or higher currents. And they just say, well, if I don't do this, I'm going to destroy myself. So that's why they shut down. Anything else?
Nope.
Well, it sounds like it. I want to thank you very much for inviting me. It's not the first time I've spoken at the San Diego DX Club, and I'm honored to have been asked back. So thank you very much.
Thank you.
Thank you, Kristen.
Very good.
Are you going to Santa Maria, Kristen?
I'm not decided yet. So I'm trying to figure out if I can swing it or not. I've got a bunch of travel coming up. I have to go back east in April as well.
We're going to be there if that.
You're going to be there? All right. Well, that's a point in its favor. So I'll see what I can do. If I go there, I'm going to fly myself because there's an airport right there.
Yeah. Okay. Hope you do.
All right. I will seriously consider that.
Somebody say something.
Mr. President.
I put him to sleep.
His brain exploded from the math.
That would make sense.
The X Club is muted, so.
Oh.
Yeah, it is.
Yeah, they are. So if nobody else cares, Kristen, so I've been doing the ARRLF interviews. And, if anybody has any doubts about the next generation, just when you get cynical because you read too many negative newspaper headlines and whatever, these kids are so fabulous. This year's crop is magnificent. I mean, one is better than the next. And it's like, oh, can't we fund them all? We know we can, but that's how good they are. And their stories and what they're involved in and their competencies are just wonderful. So I was paired this year with Art Zeigelbaum,
Yeah,
And
Art's a good friend.
oh, we're getting along like this, you know. So it is great. It's a wonderful pair. And the kids, that's my point. The kids are just fabulous.
Oh, that's so great to hear. You know, I do get, you know, kind of cynical at times, and it's so great to hear that. It's very encouraging.
This is where giving it back is what it's all about.
Yep, absolutely.
Battery is low too.
Oh, it's always.
Yeah. Channel 8. It's channel 8.
You're good now.
If you unplug it, you go back to the microphone and the camera, right?
Yeah, I'll try that.
Can anybody hear me?
Yeah, we
Yeah,
hear
we
you
hear you.
fine.
Mhm.
Just fine.
You on the computer?
Okay. The mic is broken on this side. We did have a question for Kristen.
Sure.
You want to get up here and yell at her?
There, is the mic on the computer?
Yes.
Hi, this is Jim K6WX. Thanks. We've met at
Hey.
lots of other places.
Yep.
One thing that's always been puzzling to me is about matchboxes, and I know that's kind of like a whole different topic. But I know I have a K3, and so I do not have a 160 meter antenna, and I don't have a 60 meter antenna, but I can at least get a little bit of power out from my 80 meter dipole to get it on 160 and 60. So what's really going on there? I mean, there's this, I mean, it's not burning up or anything, but I know it's a horrible mismatch, but a lot of what you said was that SWR isn't always the final answer, basically.
Yeah, yeah. You know, and the most clear example of that is a 50 ohm resistor being a 1-to-1 SWR match, which is totally dissipative. But what's happening probably in your situation, and this is just speculation on my part, is that the matching network itself is dissipating some amount of power because the components are being pushed towards limits of what they can handle and still be good components. And the antenna will get some of that power, and the rest of it's going to go somewhere, so probably into heat somewhere. And the antennas will have a different pattern than you may expect because you're driving them at some other frequencies. So they'll have little spiky parts and lobes and things like that. But if the components in the matching network are at all lossy, and if you have, for example, the inductors, if they have ferrites in them, that ferrite can get very warm because of hysteresis losses and other losses, and that's where the energy will go.
Okay. Well, I mean, I know it's a horrible thing to do, but it kind of works once in a
As
while.
long as it kind of works and nothing's breaking, hey, more power to you.
More power to your antenna.
Exactly.
Does anyone have any other questions? Great. Well, thanks very much, Kristen. And I have a few items here. Can you key up a few important items for the DX Club here before we go
If
to
you
our.
don't mind, I'm going to bug out because
Sure,
I'm at my office and I need to get home.
Great. Thank you very much.
Okay, thanks. Take care, everybody. Hope to
Thank
see you
you.
at some other event.
Well, this one's different.
Hit F5.
Up against the wall.
Well, I guess we can just use this.
You know what? I'll just scroll the slides. So I have a couple of items here that I wanted to discuss that have come up since the last meeting, and I thought it's important that we discuss it as a group. I don't know if we can resolve anything, but the first item was we got a notice from. It's not showing anything here. There we go. Let me get you probably can't read that, so I'll read it. This is a note from Bill Shell, K6WX, who's our representative to the DX Advisory Committee, the Southwest Division representative to the DXAC, which handles DXCC and whatnot. And I'll read this to you. The DX Advisory Committee recently discussed the current DXCC honor roll threshold, which is presently at 331 out of 340 possible DXCC entities. During the discussion, the possibility of lowering this threshold in the future was raised. Several approaches were mentioned. One idea was to establish the threshold using a percentage somewhat lower than the current level of approximately 97.4% of the DXCC list. Other suggestions included setting a fixed number lower than the current requirement, for example, 300 entities, or some other value that might better reflect today's DXCC environment. We're an ARRL affiliated club designated as a DX club, and that's why he contacted us and contacted other DX clubs that are ARRL affiliated. I would like to solicit input from your members who are active in DXing. Specifically, we would appreciate hearing your club's thoughts on the following. Should the DXCC honor roll threshold be changed? And if so, what threshold would you recommend and why? The DX Advisory Club will meet again on April 16th when this topic will be discussed further. If possible, I would appreciate receiving any comments or recommendations from your club prior to that date so they can be considered during the discussion. Thank you in advance, blah, 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 73 Bill Shell N6WS. Anyone on Zoom have any comments?
I would say keep it the same.
Okay.
I would
Somebody
say
has to work toward, give somebody something to work toward.
But there are so many entities that are no longer, they're on the list, but no longer workable.
There's 6 that are workable, but they have to be on a de-expedition. You work them when you can. I've got 6 more to go. That's all I know.
Yeah, the hard is what makes it great. If it's too easy, then you water down the challenge. So yeah.
Well, I'm at 334, so
Yeah, I'm away from it, but I don't think lowering it's the right answer.
I don't either.
Yeah.
Any comments here?
I'm at 332, and probably a couple countries we're never going to hear again, but I say keep it where it is.
if you read the latest edition of the San Diego DX Club Bulletin, my comments are, I think, pretty clear. I vote against changing the requirements.
Here. I do too.
Here. Yep.
Took me a long time to get there, but I wouldn't want to change it.
That's right.
Yep.
I guess I don't know, probably can't get to the mic here. I guess I would say, of course, I'm not old far, never worked them all, and so I could just say, well, screw it. I had to do it, you have to do it. But realistically, I think there's plenty of plateau levels. You can get an award for 300, I think 310, 320, so on. So that's a place to get to. I mean, you can, Bernie, maybe 3UR did talk for us last year about the 25
Most wanted, yeah.
And it was his his suggestion that it's still possible to get the XCC honor roll if you started like 2 years ago. You can still do it. Following one of the expeditions. There's only like, well, no, there's like 9 entities that haven't been on for umpteen years. That would be the only thing you could do, would be to have a disqualification criteria for a country if it hasn't been on the air for a certain length of time. But I don't know, that gets
very complex. For example, if you've made North Korea a deleted entity, it's getting rid of it. Now you could always bring it back on, but it's a shame to delete anything that's potentially going to come back on.
Well, in that case, it is a country. Province Island. Yeah.
Yeah. Jim, you had a comment.
I'd just like to say this, I'm 315, and at my age, I might never make the honor roll, but I still agree, I think it should be kept where it is.
Yeah.
Even though I wouldn't make it, I think it should stay where it is.
Okay. I may send a blast out, Bob, if it's okay with you, to ask the membership to comment, because it seems like it's pretty unanimous that we want to keep it where it is. The next item is Escondido Amateur Radio Society years is having one of the two radio auctions that are held in the county. The other is the Palomar one. This one is going to be in Escondido on April 25th. It begins at 8:30 in the morning and buyers at 9, and auction actually begins at 10 a.m. And Bud, do you know where the actual location is going to be?
It's on 4th Street, 4th Ave.
Okay.
Street 4th Avenue. It's at Dirk Wesley's CPA office.
Okay. We'll get the address out for anybody that's interested. I will put that in the last email if we do it. The next item is we got contacted by this fellow, Rob Campbell, KM6HBH. He's a software developer, and he's been working on a project called spottedham.com. And he created a club filter that allows you to generate a custom page on Spotted Ham or a widget for your club's website. So it automatically displays the list showing only club members who are currently spotted or are active on the air. And it's completely free and runs automatically. And he's offering it to us if we'd be interested. And he has a website, www.spotedham.com/clubs/top coder or something. Anyway, if you guys are interested, we can set it up so you can see where our fellow club members are operating. Although from my standpoint, all I have to do is turn on my radio and I can tell who's on the air, at least in San Diego. So if you're interested, let us know and we'll discuss that.
So we kind of used to have that years ago. Rick and D and Jim and CYA and everybody else we had some kind of back in dial-up. It was really a long time ago. We had these computer terminals with green letters on the black background, and we were on some kind of modem. Anyway, we were all interconnected, and so we could all see what each other was doing. And that was actually, and there was a 2-meter frequency that we used to use, 144.415, I think.
Yeah.
And so that's kind of gone by the wayside. It's actually kind of handy. So Gary Watt locally, I think, is that I don't have a quick way to do that. I mean, you say you get on the air and find who's on, but you're talking about 7 bands and frequencies and stuff. So I think it's a good idea. If people will do it.
Well, I think this guy's software is basically going out to harvest and all the clusters.
Still bring back those, yeah.
And then he's got a list of all your club call signs.
Right.
And it sees any of those, puts them in your clubs list.
It could be done geographically too.
Yeah. So it's just another cluster, really.
Right.
Can you guys online hear the discussion here?
Yes.
Yeah.
More or less.
Un poquito.
Okay, well, we'll look into that and perhaps set that up. It's no cost and it's just something else where you could listen to what's going on. There's a couple of newsletter corrections. These are my error. I was rushing to try to get my content to Bob and I kind of made some typos. First off, the bash is going to be on July 19th, not July 21st. And it will be starting at 1:30 in the afternoon, area 4 at San Diego Park, same as last year. It's on the Sunday in July. So that's a correction just to note, and we'll have it in subsequent newsletters, correct? Also, Linda Selder is a new member, and she was erroneously listed as Whiskey 6 Queen Alphas. She's actually Whiskey 6 Queen Elizabeth. So our apologies to Linda for fouling up her call, but that's a correction.
It's on at 11. What time is it? What time's the bash?
1:30 in the afternoon, 1:30 to 4 or thereabouts. We have it actually from 9:30 in the morning till 5, but we'll get the food there about 1:30, something like that.
And Linda has been a friend of mine for many, many, many years. So definitely, I like that we're welcoming her.
Good. There's a couple of other things. Our club is a DX club, but radio sport is something that a lot of the DXers do, particularly for DX contests. And we have a wealth of very well-known world-class contesters here in San Diego. So if anyone's interested in contesting, we can get you connected to somebody that could mentor you. And actually, you could even go see some of these contesters in action where they're working two pile-ups simultaneously, one in each earphone. It's beyond what my brain can comprehend, but if anybody's interested, let us know and we can get you connected. The other thing is, as everyone gets older, I've been hearing from a lot of people that coming to the meeting is difficult because they don't enjoy driving at night. And I wanted to float the idea of what the group would think about having a mid-afternoon meeting as opposed to an evening meeting, so we're not driving at night.
What do you think?
Any thoughts?
Doesn't bother me either way.
I was thinking, why don't we float it and let everybody think about it for about a month? Because that might be an elegant solution to having more people in person.
Okay, well, I'll put that out in the blast mini newsletter also, if Bob would be willing to do that for us before our next newsletter. The other thing is we discussed about possibly doing a field day as a club. And would there be any interest in doing that? It's hard to say. The permutations are great. We could be an emergency operating center station. We could be in a field. We could be in a RV camper. I mean, or we could do it at someone's house with a generator and use put up some portable antennas like a tower trailer or something of that sort. So is there any interest? And if there is, what type of contact or what type of class do you think we should do if we do it as a club?
There's one problem I know, like me, I belong to too many clubs and everybody wants to do field day and everybody wants their members at the field day. So if we start one, we're going to have competition with other clubs.
Yeah, but we're DXers. We can beat them.
It's not a contest.
And we have done that in the past. With K6AM and I and W6YA and K6NA. I mean, we kick butt. I mean, we set record.
Alcohol's got a pretty good setup for the tower.
So we were out of.
You have competition between Alcohol and Escondido and Palomar used to, but I hear they're going by the wayside.
Palomar doesn't operate. Escondido is one transmitter. So it's really waned back, and El Cajon is on and Poway is on, and there aren't that many clubs really anymore in San Diego that are operating. So it's something to consider. Any other thoughts about it?
Well, we have an antenna trailer. I own an antenna trailer. Bring it wherever. It has a 2 40-meter beam, a 3 tri-band, or 80-meter dipole, and we use it for CTP every year. It's very effective. We have a lot. I mean, we could do this a couple of different ways. I mean, there's probably 10 or 12 of us that are experienced CW operators. We could just do that, get max points for CW and all that. We could try to. It's really hard to get people to just show up. You know, they'll use and all that. somewhere in between, I don't know. I personally think FT8 and field day is extremely difficult to do because it multiplies the normal QRF times 10. Make it a side guided CW operation, maybe, I don't know.
And now there's a new mode FT2, which is a lot faster, but the signal to noise ratio isn't as good. So that's something they changed also.
So PARS, Poway Adventure Radio Society, operates at Lake Poway. We are so not out for blood. We're about getting people involved and operating, the total opposite of what the DX Club would do. But you could have a station within our operation at Lake Poway, and then you guys kick butt. Well, we do the goodwill ambassador for ham radio shtick.
Here again,
Those laughs, I appreciate them.
Yeah, I mean, because you haven't established what these generators.
Yes.
Yeah, I think it's important to use a generator. That's the real thing.
and then get points every way you can. Get your section communications manager to come and get a press release and all of the above. Yeah. Well, there again, we can discuss it, and I'll put that in the note. Santa Maria is coming up in April, and I encourage everyone to go. It's being in lieu of Visalia this year. It'll be a slightly different venue since it's not just DX, it's both contesting and DX. So it remains to be seen exactly how that's going to play and whatnot. I'm planning to go, but encourage anybody. I know they still have openings in the hotel rooms, which are significantly less than Visalia was.
We're going.
We're going.
We're going.
I'll have to pass. I don't have anybody to carpool with.
I want to wish everybody a happy Easter, happy Passover. Thank you for joining us.
One more thing, if I can.
Oh yeah.
Yeah, one more thing, if I can. I consistently have problems logging into the Zoom meeting using the Outlook calendar invitation that I receive. Month after month, it never seems to work.
Correct.
And I've documented all the steps and sent them off to Jerry and Rob. I copied you on it as well, but it looks like nobody else seems to be having the problems that I'm having. I get the invitation, I click on it, and it says meeting invalid. So
that's
then I
what
have
I
to
click
go.
on too.
Well, and then I have to go. I go to the. What I do is I go to the bulletin, and I click on the link there, and that logs me in every month. But for some reason, the Outlook invitation I get doesn't work, and I don't understand why. And with all these smiling faces here, I guess the problem is isolated to me, and I'm trying to find out why.
I think I've got to talk to Bob LaRose, who's not here tonight, because he's been saying the meeting ID and the passcode are correct, but the link is not correct, and I'm not sure why there's that disconnect. I'm here, so I can't tell the difference. But obviously, it's a real problem because you're clicking on the link and it's not working. But I guess
I used the link and it was okay.
Oh, you did
on the bulletin.
We copy paste the link in the bulletin in our Google calendar. Google.
That works fine. It's the Outlook invitation that comes. That's the killer. It's the Outlook invitation.
But I got enough.
Well, that needs to be changed, apparently.
Yes.
Well, if we're talking about expanding or moving the meeting times so that we can accommodate more people remotely, then we're going to have to get that fixed.
Yes.
both remotely and in person. I mean, it's a lot of no one spoke up, but a lot of people had mentioned that they're not real fond of driving at night in San Diego, and during the winter time, that's all the time. So it would be an afternoon meeting rather than being an evening meeting. But we'll do that around. It's not going to be in a month or two. It's just something to think about and see what the consensus is. I mean, unlike other democracies, this is a real democracy where democracy rules. I guess we'll do the roundtable now. Do you guys want to either come up or do you want to just speak from your location?
The microphone might be working.
Who has the mic?
Don has the mic.
Can we not look at the wall? The X Club might be muted.
We're looking at the wall.
Yeah, we're looking at the wall.
We're looking at the wall.
Yeah, come up to the mic. Come on. We want to
Up
see you.
against the wall.
The camera.
Okay.
I'm plugging it in now.
Yeah. Steve. Partner is blocking my signal.
Still against the wall.
The camera's pointed at the wall. Yeah, I know. I couldn't move it. Oh, it's oh, I see. Got it.
Turn it around. Turn it up.
There you go.
Wow.
There you go.
You're in the cliff. And is the club muted?
No.
Nope. We hear you.
How does the microphone work? Oh, plug the microphone back in. Oh, okay.
Is there a mute for?
It's just bad. Okay, you're unplugged.
Are we on?
Yeah.
You're on the laptop.
Okay. Better than nothing.
Yeah.
So what are we using for a microphone right now?
The laptop.
The laptop.
You want to say something? Go up there. Probably you can. Can anybody hear us?
Yeah, working.
Yeah, we can hear you if it's quiet. Everybody else is quiet.
Yeah, it's true.
Okay. Good. It works.
Right.
Probably work better now.
Jim, start.
You're cricket. My power supply died.
Introduce yourself.
I'm Jim K6WX. And I got a IC 7300 and a Samlex power supply. And last week came in and the fan was really, really loud. Turned the power supply off, turned it on, that was it. That's all she wrote. But the power supply is about 2 years old. It's probably had a 1 year warranty. But it actually had a 3 year warranty and new power supplies in the mail.
There you go.
So is it a switcher? Yes. So I can't hear nothing. I can't talk to anybody, so no comment.
But you'll be back.
But I'll be back.
Well, Jim was saying he's worked 51 countries on your mic pole, right?
So far, yeah.
Yeah, that's good.
A little over 6 months, 51.
No, where?
So, well, follow me now. So, okay, Jim, K6WX, hi. Worked Bouvet. I made 5 contacts with Bouvet. I really wanted to work it on sideband because I had not. I didn't get that, but I did get FT8 and 80 meters was nice to get on Bouvet. I've worked several CY0S is on now. If you haven't worked, it's not rare, but rare-ish. If you haven't worked, it's up easy right now.
How much power are you using?
400 watts.
We'll get to that. That's why I can't get it through with 100.
And so S21 WD's on right now from Bangladesh, which is a tad rare. I worked them on 12 meters last night at 10 o'clock. And I was like, I have no idea what propagation path that was, but there it was.
What mode?
FT8. So we are going to Santa Maria. John and I are going to Santa Maria. I am a DXCC card checker, and I'll be doing that there. You have, obviously you can come to me anytime if you have some cards that need to be checked, but I'll be doing it there. And then, we talked some about field day. As I say, I'd be happy to bring the antenna trailer down from Ramona and set it up. Well, need help setting it up, but we can do that. We use it at CQP every year out at Desert View Tower, and it works very well.
Steve, K6WX. I managed to work Bovee 10 meters and we had what else? I had worked them many years ago on 20 meters, so yeah, it wasn't new, all on new for me, but I will say the J51 the expedition, in my experience, was probably one of the best organized and most effective that I've seen. I've done 4D expeditions on my own, and I'm just in awe of the great job that they did.
They made over 200,000 views.
Yeah, I worked them 6 through 160. So
yeah.
I'm a happy camper.
Tom, W0NI, no report. Hello, Carlos and Lucas. You guys are looking good. See you all. New ham next to me, said Mayor Reese so.
Thanks, Tom. KNX. Sorry. I remember this thing. K6TXI. I'm pretty new at this, obviously. I just got my license about a year ago. And I don't have any equipment. A long time ago, I had an old Sony I spot the desert with. Was I think a 2010 Sony. And I used to get this faraway station. I really enjoyed that, but I never actually talked to anybody else. Because you just listen in. But now I want to buy some equipment to get more involved in DX.
Nice to hear about. How did you hear about us?
Internet.
Okay.
Research.
Welcome.
The local guy could be.
WR6HGA, Linda, nothing to report.
SSDH Jim, actually both Linda and I worked at X69 and CY0. Didn't get the CY0K, although I haven't confirmed this for the advanced weather operations, but that's about it.
Going to Santa Maria.
Yes. See you there. Well, good, we'll see you there.
Yeah, 60-hour, nothing to report. It says PTF, it's like flying a full plane.
Nothing. Okay. I'm Ray, WA6MDL, and I've been trying to work that Bouvet Island, and they are all over 60 meters, but how many of you all know that we're only allowed 9.15 ERP power, and I see signals that are way much louder than that are making contacts, and my little Pee-wee signal there, less than 10 watts ERP, does not stand a chance. And so, yeah, I'm wondering now if somebody works them, what do you guys think about disallowing if they work the illegal power to make that contact?
That's only the one due to frequency. The other one you can run 100.
Oh yeah, that's right. But they're only on that one channel. They're only on channel 3.
Didn't bother us.
And so I saw all these people throughout the whole country making contacts. I'm looking at their signal strengths. And I'm going, these guys are running a whole lot more than 10 watts ERB. And so if they made that contact, is that a valid contact if they're running more than what's allowed?
Well, the weird part of that is that there's no DXCC credit for 60 meters.
Oh, right.
Yeah.
Then why are they there?
To get on the air because you can.
Well, they're wasting electrons in space.
Well, they're paying hogs.
So anyhow, that's all I worked that. I didn't work them, but I worked for Sable Island though.
They're going now.
It is going
to those.
Yeah.
The CYO.
CY0S.
0S, they've been doing lots.
Yeah, and I mean they're on all the time.
Yeah.
They're on channel 3, which is the one that last month it changed.
Yes, February changed.
So there's a semi good chance of working CY0S on 6 meters. Just pay attention to the whole piece. So Terry and 60W and I worked another previous operation several years ago. Like there was this window working, boom, they're gone, but it happened.
Less than 5 minutes.
Yeah.
Wow. Okay. Well, yeah. Thank you.
About 86 pH. I did get Bouvet 20 and 40. I was really shocked at 40 because the propagation maps that ain't happening. But I heard them. I threw some calls out. They heard me.
They were really loud the first 2 nights on it.
Yeah. Then all the latest comes in. P1, C1, that's
Got a lot of good stuff on the air right now.
there's a lot of fun and good stuff. The target rich environment. W10, W6 TED. I did not get Bouvet. I tried, but then I traveled too, so it kind of cut into a lot of the radio. I was a little upset about missing Bouvet, and yeah, and then K went up pretty high or towards the end too. So so I missed that, but I've been having pretty good luck with some of the others, J51 and all that, no problems. I primarily work CW, so I don't work FT8 that much, unless I'm desperate. I did try to get Bouvet on FT8 because I got desperate. And then the only other thing to report, so I've got a ham since what, like 2018, something like that. I did get my DXCC single band CW endorsement, my first one, on 15 meters. So I was pretty happy about that.
What's your DXCC total?
So I'm around 167, 168, something like that. So, and you know, it's the frustrations you get with CW and DXCC is people don't report. You know, yeah, it's getting there. But the de-expeditions, of course, are always done. You can rely on them for a few bucks. Yeah, for only a few bucks, yeah. But I get it. So, yeah.
Yeah, 6 IT mark, like all of you are in the mod. I got the Bouvet few bands, but limited in time, so all else is good. That was great talking this session too.
Yeah, we all enjoyed the talk. You guys are tired of listening to me talk, but I'll go to the Steve. Do you have anything to say?
Well, I got Bouvet, could hear them twice on two different bands. They were nice and green, very strong signals. Was also picking up all of the US and Europe too. And I was wondering if I was getting it by long path, but with the antenna I got and 100 watts, they never responded to me.
Nobody mentioned the DX contest. Both the phone and CW were a lot of fun, although propagation did not hold up the entire weekend on both weekends. So, but they were fun. We'll go to Zoom now. Greg, WA6YLR, you're up next.
Yeah. Okay. Yeah, I obviously tried to try Bouvet also, but I've got HOA restrictions here. I went so far as to, once it got dark, I have a school next to me. I strung a 40-meter antenna out to the school. tried to point it south and ended up getting lucky and hit actually the J51A out of Guinea-Bissau. Had a DX expedition going, so I was pleased with that, even if Bouvet didn't hear me. So I had fun. Tried a whole bunch of different antennas, and Noel, who just got elected into the club, was helping me. He was offering to bring over antennas and to help me test out stuff, and so it was a fun adventure, even though I wasn't successful. That's the part I think people need to know about when they're striving for that honors listing. So it's the challenge. So anyway, had a great month of just trying to get some distance stations. So yeah.
Great. Well, thanks very much for stopping by. Bob, K9RHY, you're up next.
Hi, yeah, well, no new news, but I want to direct everyone's attention to the March bulletin and check out pages 15 and 16. You can access that either via the copy that I sent to you via email or on the website. All the DX Club bulletins are on the website and available going back years and years. But check out the latest one, because this issue of changing the requirements for the honor roll is something that's been kicked around for a long time, and some of us have strong feelings about it. So my 2 cents worth is in there. So other than that, I stayed away from Beauvais because I've got them on many times on many bands and didn't think I'd add to the QRM.
And there was plenty. Well, thanks very much. And I'll mention to Bob about the problem with the. I'll have him look into the link to make sure that that's okay. Some people it worked and some people it didn't. Gail and Mike, you're up next. How things in Cabo?
Things are absolutely wonderful. And did you all hear me chatting with Kristen about the ARRL Foundation scholarship interviews?
Yes, we did.
Okay, so I don't need to repeat that, but it's going really well and it's really wonderful. It's a challenge, but it's all about giving back, as we retirees know. So that was good. And it's wonderful down here. And we had Jim and Joan and Tom and Ella came and visited us. And that was a great highlight. It was absolutely fabulous. Thank you for coming. And see you in Santa Maria. And I am facilitating the YL Forum.
Surprise, surprise.
So I don't have anything new since we've been down here for 2 months, and I listened in to see if I could hear Beauvais. I could hear the pileup, but I couldn't hear them. So we only have a vertical down here, a 4BTV, so it's a little troubling. And also we have a power line that's about a half a mile away that gives us about S7, S8 noise all the time on all the bands. Makes it a little tricky to get anybody weak. But we'll operate illegally down here once in a while. We'll just pretend we're on a boat offshore a little bit, and it doesn't count for any awards or anything, but just to make sure the radio's still working and do an FT8 contact or something.
Who do you think you are, Don Miller?
Yeah, that's right. Yeah, Don Miller mode. So the what else was I going to say? I forgot. Anyway, see y'all in Santa Maria.
Great. Have a safe trip coming home.
Yep. Luckily, no TSA problems down here. They're not the same agency.
I just want to know, are OMs allowed in YLRL?
No.
Ron, you're up next. N6XT.
I only worked one new one. I tried Beauvais, but I've got them on a couple bands already, so it didn't really matter. It was FT8 and the pileup on the East Coast, and the guys were not running 50 or 100 watts. Running a KW on FT8. They were that wide. I was watching them on my Flex. And so I just basically worked, let's see, what did I do? I worked Chad, Tango 1, Golf Delta over in Africa. I think it's South Africa. That's the new one for me on 15. Got a field day coming up with a group here. We're on top of a mountain, 700-800 feet, running 100 watts of 1 alpha. It's hard to get them involved. I think we have a total of 8 people last year. I don't expect many more than that. They don't even have anybody to run it yet. So I volunteered once and I was beating the bushes. I only got 8 people to work it. So it's just more or less a social gathering for that club. So that's my tuning. I'm sticking to it, guys. 73 DX.
I guess you'll have to do blocks, 2 hours of CW, 2 hours of phone, and an hour of FT8 or something like that.
No, actually, they only do it SSB and FT8, and FT8 maybe 10 contacts last year.
Oh, yeah.
Yeah.
Just a comment on low turnout. We're a member. We were a member anyway. I think our thing is expired, but anyway, of the Cayman Club, and that thing is they do field day because they're in North America, and that is a real social thing. They go down to the beach. They have a fish fry. They bring all their radios down there, new antennas, and try them out on the beach. And they told me, I said, how'd you do it? They said, we did really great. We made about 12 contacts.
Different priorities.
How many cervezas?
12 on all bands.
That's great. Mel, you're up. K6SY. SY.
That's why. There we go. I worked Beauvais a number of times. Didn't really need them, but I played around with it. I haven't been really active, but I did want to comment on one thing. Changing the hours of the club to an afternoon so you don't have to drive at night is the same problem we had with the Southern California DX Club. And ultimately, it ended up closing down the club because we couldn't get any young members to participate. And I'm looking around the room there, I think you have the same problem. You have to be careful, otherwise you're not going to be able to continue the club because there's not going to be anybody to replace you. So you need to think about how you're going to schedule the hours. That was the big problem as the Southern California DX Club had. We just couldn't handle people driving and then trying to change the hours so they could come during the daylight. It's a real problem. Ultimately, we simply closed the club down because we just didn't have enough people.
So Mel, would you suggest we stay as an evening club and those that want to drive will drive and those that won't can zoom in? They can still.
I think that's best. You got to do something to encourage young people, though, to come and fill in the club, because that was the big problem we had. And we had a number of people who chased away some of our younger members, made a real problem out of harassing them over the fact that they were working FT8. And they labeled it the bad band, and it was that kind of awful, actually. But if there needs to be some way to encourage young people to come into the club, otherwise, 10 years from now, you won't have any members at all.
It's not just the club, it's ham radio in general. There are not that many young people joining ham radio.
Well,
two or three of my harmonics are hams, and they never go on the air ever.
Yeah, I know. I have the same problem, but my daughter lives down in San Diego, and she's going to be coming to the convention, so hopefully she'll be able to meet some of you guys. But anyway, my grandkids, it's a different world. They all live at home, even though they're all college graduates. They still live at home because it's too expensive to move out, and they're limited to what they can run. So it's kind of a problem. They're on FT8 and that's it.
Okay, good. Well, thanks very much for stopping by, and thanks for your input. Brian, you're up next.
Okay, thanks. First I'd say the link worked for me this time. It didn't last time, or the time before last. And so it worked for me. I just clicked on it from Bob's email and it worked. The only other thing I've been receiving a lot of these electronic QSL cards. I don't know if anybody else is getting them. And they're like 2 and 3 years old, 4 years old. And I'm just putting them off in a folder on my computer because I can't really use them for anything. But and some pretty bad because some of them, some nice places I'd like to have a card from. But I have gotten a number of cards through the bureau, so that surprised me. But other than that, nothing new here on this end.
Good. Well, stay cool and stay safe in Texas.
You got your tower up yet?
No.
Could we, I'd like to ask Mike and Gail just a quick revisit to the Poway Field Day. What do you guys do?
What do we do?
We do.
Where
do you go? What equipment do you take? Who's involved in all that?
The last few years, Eric was there. He brought his K4. We have who's at
he's in Colorado now.
Don Hessig brings his RV with his RV antenna on it. They do FT8 a lot. Another guy brings his G90 the last couple of years.
There were 2 stations from South Bay that showed up.
Yeah. You got to let us know if you're coming though, so we can change put the right classification at the beginning, because they showed up.
Who's going to run it this year?
Who's going to run it? That's a good question.
Because John and Success WST did it last year, but who's going to run it this year? Do you have anyone designated?
No. That's always a problem, you know.
When we get back, we'll go to the breakfast, and if there's real sincere interest from the San Diego DX Club, you know, I'll be a little pushy and say, hey, you know, we have done the publicity. We've gotten some newspaper coverage.
We usually get the councilman to come.
Yeah. City councilman. And so, I mean, it's really fluid right now, but it's not a great signal location, but it's a great, beautiful location. And we'd love to have you join us and just set up seriously and just run all night.
Yeah. Brian Tagg usually brings the tower trail. It's not very tall. It's like 25 feet with a tri-bander on it. So another antenna, good antenna would be good, because I usually supply a bunch of wire antennas, but you know, wires work.
Oh, and we usually we have some students involved.
Yep.
In a balloon launch.
There's usually dinner.
Oh yeah, big barbecue dinner.
What's important?
Yep.
Last year I operated a little bit there. They didn't have a CW key of any sort, and they didn't have any headphones, and people were, you know, yakking in the background, and you couldn't hear the stations, and it was not ideal for operating in any way, shape, or form, even though it's not a contest.
My opinion is that if you want headphones, you better bring them, because I'm not lending my headphones to anybody, and I'm not using anybody else's headphones.
Right.
So having a CW key is something. If we knew we were going to have a CW operator, we could have gotten home and gotten one. We got 2 or 3 at home. So yeah.
Well, as Jim said, you get more points, so it's worthwhile to spend a little bit of time on CW, even though you may not have 40 word a minute operators.
Yeah, right.
And it's a real easy exchange, so it's something to consider.
True. Oh, by the way, I just thought of one thing I was going to say during the roundtable. That new ham, I forgot it's called KN6 something. If he's looking for a radio, I got 2 or 3 in the closet if he wants to use radio. Yeah, give me a call or email.
When are you coming back to San Diego?
We'll be back on the 3rd.
Okay. I'll have him get in contact with you then.
Okay.
Good.
Thank you.
Anyone have anything else? If not, we'll do our drawing here. Great. Well, thanks for coming by. Merry Christmas. Happy. I'm all messed up in my months. It's been so hot I can't think straight.
Merry solstice.
Easter. Happy Passover. Thanks for stopping. And we'll see you either at Santa Maria or see you next month at the club meeting.
Right. Equinox. Gail corrected me. She's right.
Happy Equinox.
Yeah. Vernal Equinox. Yeah. We're all in. Okay. Take care. Thanks again.
Right. Okay. Bye.
Bye-bye. Okay. We'll have our drawing. I'll draw the first one, and then after that, everyone else. You know, this is a DX club, so we have beer from XQ land, and we have beer from PA Netherlands. So this is all. Huh?